Hi guys, welcome back. So today we're going to look at expanding and simplifying. So this is called the distributive law because what we're going to do is we're going to distribute this value at the front here to each of the values that are in the bracket. I also call this the crab claw law because this is starting to look like the top of a crab claw. And all we're going to do when it's in brackets like this, there's this sneaky hidden multiplication sign that we don't normally write out. So what we're going to do, we're going to go 3 times by the first term plus 3 times by the second term. So this is going to become 6x plus 3. All right, let's do the same thing for this one now. So again, we're going to distribute this x across these values. So each value has to be multiplied by x. So this is going to become x times by x squared, plus x times by 5. So that's going to become 5x. So let's expand these now and simplify. So again, we're going to distribute this value across the bracket. So we're going to multiply. So 8 times by x is 8x minus, so this has become a minus now, 8 times by 2, which is 16. And then we have our minus 2x on the end here. So what we're going to do is we are going to see if we can find any like terms and we're going to collect those like terms. So just as a little refresh, a like term, it's something that has the same letter. So for example, A here, and it has to be raised to the same power. So in this case, we've got x, and that's raised to the power of 1, and we don't write that 1 generally. So if I go through now, I'm going to underline my like terms, and I've got to remember to take this symbol at the front here. I always call this like the little baby. So this is my parent, and this is my little baby. So we've got to make sure we take that with us when we move him to join up with his other family members. So 8x minus 2x is going to become 6x. And then we're left with our minus 16. And we can't do anything further with this because these two are not like terms, because this guy does not have a letter attached to him, so they're not family members. All right, let's do another example. So we're going to multiply first. So this is just going back to following BOMDAS here. So since we're adding this term, we're going to leave that for the moment. We're not going to mess around with him too much. We're going to do this multiplication part first. So again, we'll distribute this across the bracket. 2x times by x is going to make 2x squared. And then 2x times negative 4, negative 8x. So again, we're going to look for our like term. So same letter, same power. Now here, it's really tempting to go, ooh, I see an x here, so that must also be a like term with these two other x terms. But it's not, because this guy, he's x squared. He's not the same power. So we're only going to underline 4x and negative 8x. And again, my parent has to make sure that he's holding hands with his baby. We don't want to lose that baby when we join him up with our other family member. Okay, so 4x take away 8x. Well, 4 take away 8 is going to become negative 4x. And then we've got our plus 2x squared left over from before, and we can't do anything with him because we don't have any other family members. All right, couple more examples here. So question 12. Expand and simplify 9x, take away 3x minus 2. So again, this bit here is the multiplication part. So we're going to do that before we do our subtraction part. So we'll leave the 9x takeaway out the front for the moment, and we'll do 3 times by x. So 3 times by x is going to become 3x, and 3 times by negative 2 is going to become negative 6. Now, we have to be really careful with this because we're minusing all of the things that we've just calculated. So when we minus a negative and a negative are going to make a positive. So this is going to become 9x minus 3x plus 6 because a negative and a negative are going to make a positive. Okay, so again, we're going to look for our family members. We're going to look for our like terms. So these are the only ones that have x raised to the power of 1. So this value is now going to become, if I've got 9 lots of x, take away 3 lots of x, that's going to be 6 lots of x plus 6. Okay, one more question. So question 13, we have to, oops, made a little mistake there, expand and simplify 3x squared minus x 2x plus 5. And again, what we're going to do is we are just going to do the multiplication part first because we're going to follow BOMDAS. We're going to leave the subtraction part until afterwards. So we're going to leave the 3x squared minus bit for the minute. Okay, so let's go ahead now and let's expand across our brackets again. So x times by 2x is going to make 2x squared. X times by 5 is going to make 5x. Now we're subtracting all of this, so subtracting 2x, and we're going to subtract 5x. So this becomes 3x squared minus 2x squared minus 5x, because we're taking away everything that's in the brackets now. So let's look for our like terms, our family members. So again, we can see here we've got a case where we've got a whole bunch of different x's, but we just want to collect the ones that have the same power. So these are both x squared, and again, I'm going to make sure I take my baby with me because I don't want to lose him. So this becomes 3x squared minus 2x squared, and that's going to become 1x squared. So we're going to write 1x squared. And we can't do anything with this 5x. He doesn't have any family members, so we're just going to leave that, and that's as simple as we can get it. So that's how we expand across brackets, and again, that's using the distributive law or the crab claw law because it kind of looks like a little crab claw. And then simplifying by collecting our like terms, so looking for our family members. Alrighty guys, I will see you in the next one. Have a good day.